start off with a very, very simple problem. I want you to solve this problem, and then I want you to graph the answer to the problem on a number line. So solve this problem, 3x plus 7 equals 13. Figure out what x is, and graph its solution. All right, what'd you get for x? 2. What's the first thing I've got to do to solve this? Subtract 7 from both sides of the equal sign to maintain balance. Okay. Now I have 3x equals 6. Now what do I do? Divide by 3 on both sides of the equal sign to maintain balance. To get x is equal to 2. So I can graph that solution. Now what if I was unsure that the answer to x was 2? What could I do with my solution? Kyla? Right, where I substitute x for what? 2. No, where I substitute x for 2. So if I wanted to check it, it's called substituting. Since I know x is the same thing as 2, I can go ahead and substitute that in there and solve. Is 13 equal to 13? Then I'm confident in my solution. So that's the very first type of solutions you can have. You can have 1. So if you can graph your solution on a number line, your equation has only one solution. So aka your variable will only be equal to one value. This is the one that we've been dealing with for most of our mathematical lifetime, is equations that have one solution. Brace yourself. Can you see it a little bit better or worse? Better, worse? Worse.
Yeah, I'd say worse too. Worse.
So that's better for you? All right, so if we can have one solution to something, what other types of solutions do you think we could have? Hunter?
No solution.
Okay, no solution. What else?
Infinite.
Infinite solutions. What else? Valerie? You can have 2 solutions, right? So let's think, we're not really going to focus too much on 2 solutions. Let's say you have the square root of 25. Can't the answer to that be either 5 or negative 5?
Yes.
Right? Negative 5 times negative 5 is 25. And 5 times 5 is 25. So that has 2 solutions. We're not really going to focus on that type of solution. We're going to focus on 1, infinite, and none. Let's look at this example. 3x plus 5 plus 2x equals 5 plus 5x. Solve this. All right, how many of you got something equal to the same thing? So, like 5 equals 5, or x equals x, or negative 1 equals negative 1. How many of you guys got something where one value is equal to itself? How many solutions do you think that that's going to give you? Infinite. So, I can start by combining like terms. And right now, what do you notice about the 2 sides of our equal sign? What are they?
Equal.
They're exactly the same. So if you have one side equal to the other side, or your 2 sides are equivalent, you're going to have an infinite amount of solutions. So that is the second type. Bless you.
That was like force
It's like
feeding.
doing Space Gun, Chelsea. It was someone on Star Wars. Yeah.
Gracious, are you allergic to Huntina?
I'm allergic to, yeah. Maybe I'm allergic to whatever, I'm not.
I don't know either.
What is that?
I don't know. She said, what is this? Huh? I have no idea. None of us know.
What?
What was that one point?
It's pasta.
It's a sport.
Okay, can you give us a minute so we can run ahead whenever you're trying to listen to you guys trying to talk? Or you're trying to talk.
Okay, so the second type, if your 2 sides of the equal sign are equal to each other, you have an infinite amount of solutions. Any number you plug into that, or you substitute in for x, will work. If you put 6 in, it'll work. If you put 7 in, it'll work. If you put negative 2,000 in, it will work. Okay? A value will always be equal to itself if you have an infinite amount of solutions. It does not matter what value you plug in for x. Doesn't matter. It's gonna work. I promise. Okay. So if I plug 2 in for this, would it work? If I put 7 in for it, would it work? If I put negative 17.825, would it work?
Yes.
Yes. A number or a value will always be equal to itself when you have infinite solutions. Cool. Go. Solve this one. What'd you get?
Something.
Tell me something you got, because there's probably a few different answers going around. Kyla?
I got 3 equals 0.
3 equals 0.
6 doesn't.
Okay. What else did you get? 6 equals 3. Okay. Okay, so let me ask you a question. Does 3 equal 0? No. 3 doesn't equal 0. 3 equals 3, and 0 is 0. Does 6 equal 3?
No.
No. So if I solve this, what's going to happen is I can go ahead and subtract 2x from both sides to get 6 equals 3. This is just one way you can do it. But is this a true statement? No. It is not a true statement. So if you solve an equation and the two sides of your equal sign don't match, it makes a false statement. Then you have no solutions. There is no number or value you can substitute in for x that will give you a true statement. Nothing will work. Okay, so you have no solutions, right? So if you get a false statement in the end, you don't have any solutions.
Is this still asking?
Writing a succession of equivalent equations until we write one we can solve by inspection. Let's explore if there is a way that we can determine whether an equation has one, none, or infinitely many solutions without solving it completely. Here are some things to look for. Are both sides of the equation identical? Does the variable disappear, leaving a false statement? And will the variable end up on one side and a constant on the other?
All right, so let's look at these 3 things. Are both sides of the equation identical? Which solution would match this first thing to look for? Valerie? Huh? Infinite solutions. If I were you, I might make a note next to each type if that'll help you. You don't have to, but if it helps you to make a little note like, are both sides identical, question mark. Next to infinite solution. So if you look at something and let's say you have 3x plus 7 equals 3x plus 7, do you need to finish that completely? No, right then and there you can see, oh, they're identical. There is an infinite amount of solutions. Does the variable disappear, leaving a false statement? Which type does that match with, Kyla? Which one? No solution. So let's say you have a problem like the one we just did together. Right away, you see there is an equal amount of x's on each side. So you know they're going to do what? They're going to do what? They're going to go away, they're going to make 0. And is 6 equal to 3? No. So right there I can see, okay, those variables are eventually going to create 0. They're going to go away. Is 6 and 3 the same? No. So it's probably going to have better solutions. Then that would be identical, right? So let's say you had 2x plus 3 equals 2x plus 3. Are they identical? Yeah. Will the variable end up on one side and a constant on the other? Which solution type does that match with? One solution. Let's say you have x is equal to 5. You have your variable on one side and a constant on the other. That means that to satisfy that specific equation, there's only going to be one and only one solution. Now, when we start getting into like inequalities, we'll take a look at other types. But for linear equations, these are the 3 most common types you'll have. Like I said, you can have 2 solutions, but we're not really going to focus on that at all.
All right, what did you get for this? What did you get? Infinite solutions. Okay. So, if I go through and solve this problem, so if I go through and solve this, I have to use distributive property first. 4 times 2x is 4 times 2x is 8x. 4 times 1 is 4. Negative 3 times x is negative 3 times negative 2 is positive 6. 2 negatives make a positive. Combine like terms. 8x minus 3x is 5x. 4 plus 6 is 10. Since these two sides are identical, there is an infinite amount of solutions. Okay. 5 of you put no solution. 5 of you answered no solution. My thinking is you got no solution, but did you get this as your end answer? Or the two side, what did you get for your end answer?
I got 0 equals 5. I think.
How did you get 0 equals 5? What'd you do? Where's your notes?
Oh, I see what I did. Oops.
No, I got 12 equals 0.
How did you get 12 equals 0?
Okay, so I got 8x plus 4 minus 3x minus 6.
Plus 6. Plus 6. Negative 3 times a negative 2 gives you a positive 6. All right. Let's do another one. We're only going to do like maybe 1 or 2 more together, or 3. Depends on how I feel. Then you'll do an assignment. Then you'll work on that assignment. And then you'll be done.
That's great.
It's a pretty easy day.
I feel like we're still on pre-math 1.
Are we still doing the same thing as the other class?
For now. All right, number 2. 10 times the group x minus 2 plus 15 equals 8x plus 7. Solve this. tell me if it has one solution, and if it has a solution, tell me what that is, or that it has no solution, or that it has infinite solutions. All right, what'd you get for this? How many solutions? Let me start with that. How many solutions does this have, Kyla? One solution. One solution. What is that solution? Sebastian? X equals 6. All right, so let's go ahead and do distributive property. 10 times x is 10x. 10 times negative 2 is negative 20. Bring down my plus 15. Hey, Ella.
What did you do?
That's not good. All right, after I do distributive property, I have like terms right here that I can combine. Negative 20 plus 15 is negative 5. Add 5 to both sides. Whoa, what am I doing here? It's supposed to be a plus. Stop talking, please. Stop talking, please. Subtract 8x from both sides. To get 2x equals 12, divide both sides by 2, and that's how we got x equals 6. Did you? Okay, so this has one solution. Could I substitute 6 in for x and solve to check to make sure I was right? I could. All right, try this one. X plus 6 times x minus 1 equals 7 times 3 plus x. What are you going to have to do first? Should I get you started here? Distribute what? And the 7. How many solutions? There are no solutions to this. Nothing will satisfy this equation. So if I use my distributive property, combine like terms, I see right now that these are going to disappear, right? Because if I subtract 7x from both sides, that creates 0, that creates 0, and I have negative 6 equals 21. But is that a true statement? No. So since that does not give me a true statement and my variable is gone, I have no solutions to this. Nothing I plug into or substitute in for x will make this equation true. Nothing. Absolutely nothing. Now, what if these were identical? What if this was 7x plus 21, 21 plus 7x? Then you would have an infinite amount of solutions. Trick or treat.
Okay. Trick or treat.
Is this Play-Doh?
Yeah.
Yes. Play-Doh, do, 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 do.
I just made Ava's day with Play-Doh.